In this podcast, I'm going to talk about how to solve oblique triangles using the law of cosines, specifically what happens if you come up with an ambiguous case, which is a two-case scenario in an oblique triangle. Now, I'm not going to be talking about solving right triangles. Solving right triangles, we would use SOHCAHTOA and set up a trig function. Instead, I'm going to be doing examples where you don't have a 90-degree angle, which would require the law of sines or the law of cosines. Now, to solve a triangle means to find all three side lengths and all three angles, and you have to be given three pieces of information to even start the problem. If you were given two angles and one side, it doesn't matter what side, you could automatically find the third angle right away because we know that they add up to 180 degrees. A lot of times we'll use A, B, and C opposite of lowercase a, b, and c. So let's say I draw a little picture here. Angle A will be opposite of side A. That's just common notation that we use in math notebooks or textbooks. B is opposite of B, C is opposite of C, and so on. Okay, so if I were to give you two angles and any side, you could automatically find the third angle. But if I were to give you two sides and one angle, if you were going to do law of sines, you'd have to have one of the angles be opposite of one of the given sides. We couldn't do this if I gave you side A and B, but angle C, because they don't make a complete proportion. That would be a law of cosines example. All right, so first of all, the law of sines, what is that? Erase my scribbling. Okay. The sine of A divided by A equals the sine of B divided by B equals the sine of C divided by C. There's a really great proof that develops how to find that law of sines. If you're interested, I'm sure you could find it in any math textbook. When we use the law of sines, we usually pick two of the three proportions to start the problem off. Now, in this first example, I'm only asking you to find one of the angles. I'm not asking you to find the entire triangle. And if I were to set this up, I know that A is 43 degrees and side A is 22. You can see I have a complete proportion with an angle and a side length, A and A. But I don't know B. That's what I'm looking for. And I know that my side length is 12. So if I set up my law of sines proportion, oops, let me go down a little bit. The sine of 43 degrees divided by 22 equals the sine of some angle B divided by 12. And I'm going to cross multiply. So I'm going to multiply together 12 times the sine of 43 equals 22 times the sine of B. And then to solve for B, I have to divide a 22 out of both sides. Okay, so I'm going to go to my calculator. 12 sine, what's my angle again? 43 divided by 22. I have too many parentheses in there, don't I? Okay, now make sure that you're in degree mode because we're taking the sine of 43 degrees. Hit enter, and I get 372 thousandths. Okay. Now, if I think about that, what that would look like on the unit circle. On the y-axis, 372 thousandths would be somewhere in here. I could either get an angle in quadrant 1 or an angle in quadrant 2. And both of them could be possible because both angles are less than 180 degrees. And that's what we would need for a triangle. If you do sine inverse of 372 thousandths, it'll give you the quadrant 1 angle. So sine inverse, and use the full value to avoid round off error, and we get 21 and 8/10. So B is approximately 21 and 8/10 degrees. Now that's the quadrant 1 possibility. The quadrant 2 is the supplement of 21.8, So if you take 180 and subtract 21.8, you're going to get 158.2. Now, does that even make sense in this triangle? Well, I already have a 43-degree angle. So if I've got 21.8 for angle B, then there's still room to find an angle C. And notice how A is 43 degrees is bigger than 21.8, and side A, 22, is bigger than 12. That makes sense. If angle B was 158.2, not only could I not make a triangle because 43 and 158 is over 180, but it doesn't make sense that side B would be smaller than side A. So in this case, 21.8 is the only possible angle that'll work here. This is not an ambiguous case. It does not have a two-case scenario. All right, let's look at the next example. If I set up my law of sines, the sine of 85 degrees divided by 10, equals the sine of B divided by 15. If I cross multiply, I get 15 times the sine of 85 divided by 10 equals the sine of B. 15 sine of 85 divided by 10. All right, there's a problem with this answer. We get 1 and 494 thousandths. Is it possible for sine to be greater than 1? Nope. It is not possible for sine to be greater than 1. So here's an example where we've got a triangle where one of the side lengths is dangling and it doesn't reach the other side. We have a fixed 85 degrees. We have two side lengths and they just don't match up. So this is a case that is not possible. There is no possible triangle that can be created with these three dimensions. All right, so we've had an example where we did get a triangle, and now we have one where we don't. My third example is going to be an example where we get two possible triangles, or two possible angles for B. Okay, if I set it up, the sine of 21 degrees divided by 12 equals the sine of B divided by 31. If I cross multiply, 31 times the sine of 21 divided by 12 equals the sine of B. Sine of 21 divided by 12. I get 926 thousandths. Okay, so if I were to look at my unit circle, 926 thousandths is a value way up on the top, and I'm going to get a very big angle in quadrant 1, or just on the second side in quadrant 2. Now these two angles are not going to have much of a difference. Okay, so let's find out what they are. Take inverse sine of 926 thousandths. Oops. Delete that out of there. I don't know what I did there. Okay, and I end up with 67.8. Right away, I'm going to consider the supplement. 180 minus that is 112.2. So 67.8 and 112.2. All right. Now, this is B. If A is 21, the first B plus 21 leaves plenty of room for angle C. And the second one also leaves plenty of room for angle C. So because there is room for an angle C in both cases, this is a two-case scenario. Okay, and if you look at our possible side lengths, 31 for angle or for side B is bigger than 12. So did I get an angle that's bigger than 21 in both cases? Yes. So here's the rule of thumb that we usually follow for when there will be a two-case scenario. If the measure of angle B is greater than your given angle, you're going to get two cases. Okay? And how can you tell that B is going to be bigger? Because side B is bigger than side A. Right there, you know that you're going to get a two-case scenario. Now, if you look back at our previous examples, this was a no-case scenario. Let's go back to the first one. Is side B bigger than side A? Nope. So we didn't have a two-case scenario. Okay. Now let's finish this off by applying this in solving a triangle problem, an oblique triangle problem. And we'll go through and find all three angles and three sides using the given information. So first of all, the measure of angle A is 43.1. We don't know the measure of angle B, and we don't know the measure of angle C. We do know that A is 186 and 2/10, and that B is 248 and 6/10. So right away, looking at this problem, do you see that it's going to be a two-case scenario? And again, what I'm looking at is the fact that B is bigger than A. So that means the measure of angle B has to be bigger than the measure of angle A, which is going to be a two-case scenario. All right, so what do I do first? Set up my law of sines proportion. Sine of B divided by 248.6 equals the sine of A. I don't know why I did that backwards. Divided by 186.2. That's okay. We cross multiply. The sine of B will equal 248.6 times the sine of, wait, did that wrong? No, that's right. 248.6 times the sine of 43.1 divided by 186.2. Oops, where'd I go? All right, I'm not going to remember these numbers. I need to have my calculator right next to me. Clear. 248.6 times the sine of 43.1 divided by, I put the parentheses in there, 186.2. Okay, so I end up with 912 thousandths second sine and I get my angle 65.8. So B is 65.8, or let's think of what 180 minus 65.8 would be. Put my degrees symbols in there. So if I take 180 and subtract that, move that up a little bit. 114.2. Okay, so I could have 65.8 or 114.2. Okay, now how do I find angle C? Well, the measure of angle C is going to be 180 minus A and B. So if A is 43.1 and B is 65.8, I can find the measure of angle C. Oh, too much. 180 minus 43.1 minus 65.8, and I get 71.1. Or the measure of angle C is 180 minus 43.1 minus the 114.2. Oops. 71.1. So we're going to take 180 minus 43.1 minus 114.2. Good. And I get a much smaller angle, and that's pretty typical, 22.7. Okay, now I still have to find the measure of side C. And to do this, I can't just use the Pythagorean theorem as if I had a right triangle. I'm going to have to use the law of sines again. And I'm going to have to do it twice with 71.1 and 22.7. Okay, now I would definitely recommend using the original given information for A. The sine of 43.1 divided by 186.2 equals the sine of 71.1 over C, or the sine of 43.1 divided by 186.2 equals the sine of 22.7 over C. So the only thing that I've changed in this problem are my two possible cases for the measure of angle C. Okay, now I'm just going to go ahead and calculate this by hand and not do it on the podcast, just to save time. So if you're following along with me, make sure that you're in degree mode again. 186.2 times the sine of 71.1 divided by the sine of 43.1. I end up with, in this case, that side C is approximately 257.8. And in the second case scenario, 22.7, I end up with side C is 105.2. I have to round that answer. Now this is certainly a lot of work to find all of this information. Okay, so 257.8, oops, or 105.2. Now, let's consider what we got here. This is case one. Let's make sure that our biggest angle is opposite of the biggest side. 65.8 is the biggest one here. The biggest side, nope, I'm sorry, 71.1 is the biggest angle, and 257 is the biggest side. The smallest one is 43.1 and 186.2. Perfect. Now, in the second case scenario, our smallest angle is 22.7 and our smallest side is 105.2. The biggest one is definitely the 114.2 and the 248.6 is the biggest. Now, what would the graph of something like this look like? You'd have a triangle where this would be side B and angle B. And that side length could swing in and hit in two different places. This would be angle C, which could be two cases, but angle A is set. Okay. So again, this is going to happen when you have a side length that's bigger than the given one, which means the angle is going to be bigger. And in order to find that second case scenario, you simply subtract from that angle from 180 degrees and find the supplement. Thank you for listening.